My name's Mirek Glineicki from QinetiQ. I head up the business analysis team, and Siôn and I are going to be presenting about a very exciting piece of work we've done with a major IT company, looking at how we can help them improve their software development productivity, and in particular how we've developed a system dynamics model to help them achieve that. What we'll look at is really, I'll introduce the strategic issue that the company we're looking at, and how we help them investigate that, how we undertook the model development process with them, and a bit more detail about the model as well. We'll hope to give you a model demonstration, but in talking to Kim, we'll do that probably at the end of the show, just because it's easier to switch the equipment over to do the demonstration. And then we'll talk about how the model is actually being used and currently being used, and how we're working with them as well on that, and what the future is in terms of this project. So I'll start off really by looking at this particular situation where the client has rolled out a software engineering initiative really to look at how to streamline their software processes and get more quality and more productivity from their existing resource base in terms of delivering the software that they produce. And their corporate aim is really to improve the services to create the highest shareholder value that they can achieve, really. A significant component of this is looking at automation within software development, and there's various aspects which we'll come to in terms of how you automate the software development process, and we'll introduce automation initiatives into it. And what our client really wanted to understand was, what are the levels of automation you should be trying to target? How do you introduce it in terms of the investments you need to make before you realise the benefits? And where do you really focus that investment when it's obviously limited how much effort you can put into these automation initiatives? And our model that we developed with them is a key element now of their automation strategy within that organisation. Now, in the context, to put it into context, obviously software development is a dynamic and complex problem. There are a lot of interdependencies. There's obviously a process that starts from requirements capture and ends up at delivery of a solution. But in between, there's a lot of dynamic processes going on, how you map the requirements to functional elements, how you develop the code within that, and there are various processes that you can undertake in terms of iterative development or just a standard waterfall development process. And then how you do go through the testing cycle to eventually deliver your product. Now, as I've discussed, some of these tasks can be automated to help improve the quality and free resource capacity, but you do have to invest in this, and you have to understand what the effects are going to be. And it takes time, and to gain those cost-effective benefits, you really need to look at how that's going to be paid back over time. So what are the automation initiatives that we're looking at here? So really they want to understand a strategy to introduce these automation skills and improve their quality and schedule. Now, there are four areas that we were looking at in software development, and one of them was in environment setup. So to help them look at their developer and tester environments and automate those processes so that it reduces the time that they can go to a baseline environment that they use for testing or development. And the benefits, of course, are to reduce defect rates. So where they're not consistently putting those environments up, they could be introducing defects into the software they're developing. It's an investment per application in terms of the environment that setup that they need to do. And obviously the impact of automation is they need to maintain that for reuse each time, but could be a trade-off in terms of the benefits they realise from it. They look at build and deploy automation as well, and looking at how they build the software, how they compile it, let's say, into an application that can be deployed, and how they deploy it. That process can be automated. It's done manually, but they can be automated. And obviously you have productivity improvements through the time you save, and obviously and more frequent deployments. So when the testers are developing when the developers are in the development environment, they can compile the software more frequently and deploy it to test to increase the cycle of the testing cycle that goes on within the software development process. Again, it's an investment to put in place automation of build and deploy, and you need to maintain that. But again, the trade-off needs to be investigated in terms of the productivity improvement you get. Unit testing. Developers do local testing when they're developing as well. And they really need, there is a process there to automate that local unit testing that they undertake, and they write test scripts while they're developing, or even before they start developing, they write test scripts around their smaller chunks of code that they're developing, run those tests once they develop the code, and it reduces the defect density that they then pass on to the testing phase of the project. And again, that's an aspect that you need to invest in. You need to have the systems in place to do your automated unit testing, and you need to have your developers trained up on doing that. But it's again, needs to investigate the investment you need to make to do that and the returns you get on it. The final one, and probably the biggest one, is functional testing. This is where the testers are actually going through the full functional test of the software that you're releasing. And really, the current technology is in such a state that they can actually automate most of it, whereas before testers were entering data into fields, clicking particular buttons to see what happened. You can almost record all of that or script it and run through the scripts, and the computer can automate that process rather than a user having to do all those things. And by automating these tests, you're obviously reducing the time it takes to run them. You're running them more consistently, and you're better at detecting any faults or defects that are in the software as a result of those tests. And again, there's an investment in terms of training up your testers to be able to script automated tests. And obviously, you have to maintain that library of tests for every release of that application, and there's some time you need to invest in that. So that's the context of the problem, and where we were particularly looking at the aspects of automation and the impact it has on the software development process. What they wanted to understand, though, is at a portfolio level and also at an individual project and application level, is what levels do you want to attain, do you need to attain, and can you attain in terms of automation? You've got these 4 automation areas that you can attack, and really, what is the levels that you need to achieve to get the best return on investment? Is it full automation of every single aspect of that? Is it some elements of it? And it also depends where you are in terms of your existing application, in terms of there may be some automation already in there, and how do you build up on that? And there's also things like legacy code you need to consider that may not have automation. And so there's all these aspects playing into a very dynamic problem that you need to understand, and you need to understand the impact of some of these decisions you're going to make and where you invest in these strategies. The model development process, well, we kicked off with a client in terms of running a number of workshops and going through development phases of the tool. And we had an initial workshop, which we actually, Kim worked with us on this one, where we looked at exploring the problem, trying to understand, is it feasible to use system dynamics to model the software development process? And we explored a particular area of the software development process and did initial process mapping, looked at developing a prototype where we could demonstrate how a model would look and how it would represent the software development process, which went very successfully. And one of the aspects that we realized very quickly is that working with software developers, they quickly got the system dynamic concept. They were very good to work with in terms of understanding how you translate what the processes are, what the stocks and flows are in your system, and really got the concept and principle of what system dynamics was trying to do. So it was a really good exercise working with them in these workshops. We then went into, having produced a prototype and demonstrated that the concept was going to work, we went into a detailed workshop, a week-long workshop where we looked at mapping the whole software development process from the requirements capture all the way through design, development, test and delivery, looking at the different resources they use and how they manage their resources in terms of recruitment, training, skill sets, and then looked also at mapping the impact of automation on all those areas of the software development process. In particular, also identifying the key metrics that they want to measure in terms of seeing what the benefits are, and the data definition that you'll use to drive this model. Fortunately, for a large company like this, and because of the nature of software development, they did have a lot of data to hand, which is really good in terms of, obviously, we sometimes struggle with the system dynamics model and getting the data to back it up. They had a lot of the data that they could draw on in terms of getting historical information that we could use. So that was really good, a really good process we went through there. Went through an iterative model development where we actually used those process maps that we developed and started to pull the model together and started to demonstrate some of the processes in action. We then went through an interim workshop where we did validation with the team, and we had quite a high sponsorship within the organisation, so we had a really good set of people involved, quite a large number, probably 10 senior software development staff involved in this from various aspects, various of the software development lifecycle processes. So you had developers, testers, project managers, all involved in helping us look at how this model was going to work, how it was going to address the issues that they were looking at. And during this workshop, we finalised things like the data structures that were going to drive the initial data set that you put into the model, the interface that was going to drive the model in terms of the automation, the management levers that you could pull to understand what your strategy was going to be and what the impacts were going to be, and obviously the model outputs and the analysis that you were looking for to give you your information on the key metrics. And through some more development of the interface and the data input sheets, we then delivered the model with training and handover. Obviously, one of the key exercises was mapping out the stages of the software development lifecycle as they do it, and we went through a load of whiteboard sessions, similar to what we heard in the first talk. Big posters, really good at representing the process and seeing what it is. We had a lot of whiteboard diagrams that everyone could see, contributed to, and we got good agreement in terms of how it was being represented, and agreement in terms of the way the process works within that organisation. And using these whiteboard diagrams of stocks and flows and relationships, we built the model, quite a complicated model there. You've got a high view of it, and elements of it translated almost directly from those whiteboard sessions that we captured, and then produced the actual system dynamics model that way. I'll hand over to Siôn now, who'll then go into the detail of the model description and how we put that together.
Thanks. Hello, everyone. Okay, so what I'm going to talk about first is the model, a bit of a background about the model description itself. Then I'll go about how it's been used by the clients, and I'll hand back to Mirek about what's actually been achieved with it. So the first thing we did in the whiteboarding session was establish exactly how the software development process works. And we've got a general view that the client shared with us here. So we have a release, which is a development of a single software tool or application project. It goes through 4 key stages. First of all, requirements capture. This is when the requirements for the project are established, identified and assessed. We then move on to a design phase where there's 3 key documents written. There's a functional specification, a technical specification, and a test plan. Those documents are written by different types of staff. It then moves on to the development phase, where the functional and technical specification are converted into code, which will be the project. And while that's going on, there's also test case development, which is being carried out by the testers, who take the test plan and convert that into test cases, which can be used to test the functional specification being applied correctly in the software. So as development is going on, they'll reach a point where they can start passing code to the testers, who will then carry out the test cases to find defects. Defects will be found, there's always defects in the code, which will then be either reworked, the code is corrected, or there's a correction that's been made in design documents, which then results in more development work, or the defects will be parked and not actually fixed. So they've been identified, gone through a triage process, and then flagged up as being present but not critical to fix at this moment in time. So that's a standard way that software is developed by the client. What we see there is that the phases overlap each other. In the real world, that's what happens, but the extent of overlap is dependent upon this actual development approach that's being followed. So something like the waterfall approach would have no overlap of those various phases, whereas more agile developments will have more significant overlap. The way the client developed the code for an application is that they'd have multiple releases. There'd be a release schedule where additional functionality is added to the application, and separate software development projects will be instigated for each release. Between releases, requirements will be added to the application or removed, as defined in the requirement specification, and they don't necessarily have to run in order. or in series rather. So they might be overlapping. So two releases for an application might be being worked on at the same time and then fed into the application as a whole. On top of this, we've then got multiple staff types who will be carrying out the software development tasks. There's systems analysts, project managers and solution delivery who take a higher level view of the project itself. You then have developers who do in the main coding and the testers who do the testing. And they have roles, tasks to do in each of the different phases. So for example, in the design phase, systems analysts will be responsible for one type of document, developers another type of document, and testers another type of document. And they're also in use, those types of resources, in other phases of the project itself. So there's quite a complex allocation of resources to tasks as the projects go forward. And also those resources will be applied to different releases within that application, also multiple applications within the portfolio of applications. And then on top of that, you have the different types of automation, which will be carried out by different resource types and will have a different impact on the different phases. So, for example, automated unit testing, which Mirek spoke about earlier on, would have the impact of having more work to do during the development phase, so the developers will have more activity to carry out, whereas there'll be less defects produced in the code, so the testers might have less testing to do, and the developers might have less rework to do. So once we've established with the client the generic method of representing the software development process, we then delve into the detail a bit more inside the different phases of the software development cycle. So this is an example where showing the development and test cycle. So I'll just move over this and file a laser. So we have code which is developed in the development environment. They'll reach a point where it's time to start doing the testing. In classic waterfall software development cycle, it would be you'd wait until all the code being developed the first time. Agile, you'd have a point where, say, 50% of the code being developed before you start doing the testing. That code is then passed to the testers to start running the test cases. A further complication is that you have something called the build rate, which is the rate at which you can actually pass software to the testers to test. If that's not automated, that's done perhaps once every week, once every couple of weeks. If it's automated, then the developers can pass code to the testers to test daily. So that's quite a big gain in terms of time. From testing, we run the test case against the code. That'll identify defects. The defects are then triaged to see whether they're going to be fixed or not and where the problem lies. And that is fed back to the development environment to fix the problem, which may result in more defects being introduced. So that's a high-level view of the code test triage cycle. There's obviously more detail that was worked out with the client. So as code is sent to the testers to test, there's an amount of time it takes to run the test cases against that code. And the number of test cases that can be executed will be dependent on the amount of code to be sent to the testers. Also, how long it takes to run an individual test case. So a standard test case would take the order of minutes. An automated test case would be the order of seconds. There's also a blocking effect. So there are some defects in code which prevent further tests being carried out. So that needs to be taken into account. These sort of specific flow structures then worked up with the client for each of those different phases of design, test, requirements capture and rework. And as we were doing that, we were also working out where the different automation initiatives will actually impact on software development. So automated unit tests would have a positive impact in terms of less defects, but it would take longer to develop the code. Automated build and deploy would mean that you could send code to be tested more frequently. Automated environments mean that there's less defects and productivity improvements in the development and test environment. And automated functional testing is where the test cases are automated so they can be executed very, very quickly, but there's a time it takes to actually develop that automation for the test case. So we worked out these software diagrams with the client for each of the various functional areas. So we had user involvement, adding to the requirements capture element. That then feeds into the work which is designed and developed. Then on to testing, which identifies defects, which then results in rework. And when you carry out rework, there's a chance that we actually introduce further defects, so you carry on this testing rework cycle. Associated with an individual project, we then have a few functional areas which look at the automation piece, so automated unit testing, environment setup and build and deploy. And on top of the project level, there's then the application level. So as I was saying, the projects fall into a set, the application is a set of projects which add functionality to the software product. So we need to keep track of the requirements that have been added to the application and dropped. Libraries of test cases, test case components, unit tests. And the importance of this is that when you do a subsequent release of a software product, you don't have to rewrite all the test cases. Because you want to redo the testing on the legacy code, but all those test cases are written, so you need to know how many test cases you've already got ready and how many you need to add as new. And then defects. So of the part defects, they be carried on through the life cycle of the application. Down below, we've got some representation of the resources, so staff, numbers of, and skill levels, and then some specific training associated with different levels of automation, and then the cost elements. So sitting beneath each of those functional areas is a stock flow diagram. Sorry, Lee, wherever he is, this is Parasim rather than Bensim. I'm sure I'll have some stern word for him later. But we chose Bensim for this modelling assignment. We use both tools. And then, as Mirek showed you then, there's a big, huge model sitting underneath there, which obviously the client doesn't want to see ever, really. So we developed a management interface for him to use so he can test his strategies. So I'll demonstrate the model. Is it now okay to demonstrate, Kim? Is it okay to... So this is the management interface that we handed over to the client to actually use and develop their strategies. Something quite interesting here, something that Lee raised in his presentation, was that, like with Lee's client, our client wanted to see the key inputs and the key outputs at the same time. So we had a number of screens which had both displayed simultaneously. So on the left-hand side, we've got the key management levers to test different automation strategies. And then on the right-hand side, the key metrics that they were particularly interested in exploring. So I'll just do a quick run, and I'll take you through the different outputs that they were particularly interested in. So this is running through, I think, 2 years' worth of projects. And it's a release cycle of 4 projects for a single application. And the 4 key outputs that they were interested in was, first of all, the release schedule. So this shows 4 projects being worked on and the different phases that were being worked on over time. A quality metric, which is defects left in the code. The dynamics we see here is that for the 4 releases, it starts off with the defects increasing as they're inserted into the design documents and the code, and then it gets worked down as the testers start doing their stuff and identifying them. And this builds up as you get a backlog of undiscovered defects in the code. We have capacity measures, and the red at the bottom is bad work. So this is things like rework, fixing things that have been done incorrectly. And the green one is good work, so this is stuff that they're doing which is value added, so it's the initial development. And then the blue line here, and this is what they were particularly interested in, this is the freed up capacity. One thing you'll notice on this, the key output, is that the cost isn't there. What they're really interested in is freeing up capacity for the developers and the testers. And so what they wanted to maximise is the amount of blue on that graph. Because if they freed up capacity, if they got the testers and developers freed up early, if they've reached the quality metrics early, then they can be off doing something useful elsewhere. And that's what they wanted to really maximise. And then on the right-hand side, it's scope. So this is making sure that each release develops all the requirements that are required for that software. So that's the tool that was handed over to the client. And I've got a few slides there, just to show the sort of analysis they've been carrying out on the automation piece. So I've got a graph here which shows 2 types of graph. The top one is what the developers are doing over time for, I think it's a 7 release project and application rather, and what the testers are doing. There's a thin line which shows a baseline case. This is without any automation whatsoever, so all the simulations are against the baseline. And the bottom one is defects introduced into the application. Again, the thin line is the baseline with no automation. The thicker line is with the automation strategy implemented. And the first one we've got a graph of here is introducing automated unit testing. So this is where the developers create some unit tests, which they develop prior to doing the coding, the impact of which is there's more developer efforts over the lifetime of the application, but reduced defects, so it has a quality improvement. The next slide shows the impact of automated functional testing. This is where the test case, the manual test cases are converted into automated test cases, which can run very, very rapidly. The impact of which is the testers have got a huge increase in their workload. The reason for this is that although the test cases themselves are very quick to execute as they've been automated, the actual process of automating them is quite a slow, labour-intensive process. And they're not actually realising any benefits in terms of quality improvements. And the reason for this goes back to one of the other automation types, which is the automated build and deploy. And so they're spending lots of effort creating the whizzy, super fast running test cases, but because the code's only been sent to them once a week, they're running all the test cases and then sitting back and waiting for something to happen. So they're not really able to get the benefits in terms of reduced defects. And so that's the next strategy we're going to try. So this is automated functional testing, and this is with the additional automation strategy of build and deploy. So again, we've got an increase in tester effort, but now we've got that improvement in terms of defects within the code with it. In terms of how the model's been distributed to the client for use, we've gone through the simulation model and management levers, and this, as I said, was developed in PowerSim and distributed to the project teams to use in a runtime version, like PowerSim Cockpit. Associated with this architecture here is then a Excel spreadsheet, which the project teams then use to put in their specific requirements, so their release schedule for their particular application, how their teams are structured. And then the management levers on the interface are used to test out different strategies, and then we have the outputs coming out of it. So they've been using it to develop action plans, strategy plans for automation, and then the plan is to implement and monitor that on an ongoing basis. So that's the architecture, and this is how they're actually using the model in the client organisation. And at the moment, they've trained up 15 internal experts, internal champions on using the tool, who are going around and working with project teams to represent their particular situation, their application, their release cycle. And the way that the champions have been working with the project teams is, first of all, they have a quick meeting to establish the initial conditions. So what's the application like? What's the release like? What is the staff competency like? And then there's a phase of calibration to make sure that the model represents realistic historic behaviour. And the one thing that's come out of this calibration phase is that although the client organisation is huge and got lots of historic data, there isn't in the software world a unit of measure which can be used to describe software projects on the way it's easily describing the properties of those software projects, because they're generally pretty complicated and there's so many elements that need to be considered. But following development of the model, that's been really ramped up inside the organisation. They're trying to better describe how their software projects are developed in order to improve their cost estimation and their estimation of project delivery times. At the moment, it's largely reliant on expertise and not so much on other historic projects. Then moves on to strategy development, and again this is done offline by the champion, the tool champion, who will go away and develop lots of viable potential strategies. And then these are fed back to the project team to say, these are the potential strategies, what do you think? And then on to strategy implementation and post-review of the results. And it's an ongoing project, so the plan is to use it for each release with an application, looking back at the results from the previous release and comparing it to what actually happened. At the moment, it's being used on 3 projects within the organisation. So, back to the beginning, we started off by looking at the automation piece. How would automation improve the software development process? But it wasn't just a simple question of what percentage automation do we need to build and deploy automation, automated unit testing, automated functional testing. There's many more questions which were raised through the workshops and which the tool is able to answer. Because we've taken a look at the generic software development process, we're not fixated on a single aspect of it, but the whole thing in there. And the advantage of that as well is that it can be used for other types of questions as well. So the reuse of code, what impact would that have? Other strategic issues we want to explore, which can just be added to the code representation of the model.
So I'll just summarise where we are really with that. So the tool is being rolled out within the organisation. We have champions trained up in using the tool, helping project teams to look at their projects, look at their automation strategies, and this is being rolled out within the organisation. So really, really promising work as a result of the tool. There's additional work in terms of, as Siôn described, because the model covers the whole software development process, and there are other engineering initiatives that they're looking at, but we could easily turn this model to look at in terms of things like reuse, scenario-driven requirements capture, test-driven development and agile development are other areas that they want to look at, and this model potentially help them to do that. In terms of where the client wants to go with it is really they want to use it across all their projects, and by training their own people up and by using the model on a day in, day out basis, they are getting this rolled out, so really encouraging work there. And I think it's a really good demonstration of how they've understood the technology of what System Dynamics can do, how it can represent what the processes they undertake, and how it can model the improvements and allow them to test their scenarios, and then use this as a day-to-day tool that they can make their decisions using.